This is page 1 of the Trig and Linear Programming Review. We are doing the Trig section. The first problem says we've got triangle ABC. It's a right triangle with the right angle A. AB is equal to 7 and BC is equal to 25. So I'm going to try and draw that triangle. Let's make a right triangle. This is going to be A. Now AB is going to be 7. So I'll make this point B. So we have 7 here. And BC, that will have to be the only point left, is 25. Now, we can use Pythagorean theorem to find the missing side, or you can just remember your Pythagorean triple, 7, 24, 25. So, it looks like all of these sine, cosine, tangent stuff is dealing with angle C. So I'm going to put an arc on angle C so I can remember what I'm dealing with. Sine of angle C is the opposite over the hypotenuse, which in this case is, let's see, the opposite of angle C is 7 over the hypotenuse is 25. Cosine is the adjacent over hypotenuse, which comes out to be, well, the adjacent is 24 out of the hypotenuse is 25. And tangent of C, that's the opposite, 7 out of the adjacent, 24. For cosecant, so cosecant is the reciprocal of sine. The hypotenuse, 25 out of 7. Secant is the reciprocal of cosine. Cosine's the adjacent, 24 out of the hypotenuse, 25. This is the hypotenuse, 25 out of the adjacent, 24. And cotangent, if tangent's opposite over adjacent, cotangent is adjacent over opposite. That's 24 out of 7. Now, none of these actually are angle C. These are all just the ratios. Because angle C, well, if we look at one of these, and this isn't part of the problem, but it's worth going over. Sine of C is going to be, that was the 7 over 25. We can find out what angle C is by saying, well, the inverse sine of 7 out of 25 equals C. You can go into your calculator, make sure that our mode is set to degree mode, and say inverse sine, that's second sine, of 7 over 25 gets us 16 degrees. Reasonable number, 16 degrees. I say that's reasonable because the 7 is way less than the 24. If it was as much, then it would be 45 degrees. If it was more, then it's more than 45 degrees. So this is just going to be a 16 degree angle. On to problem number 2. Triangle ABC. AB is 48. Let's draw all these again. A, B, C. This is not at all drawn to scale, but it doesn't really matter as long as I know what I'm dealing with. AB is 48, BC is 32, and the measure of angle B is 125.2. If we want to find the area of triangle ABC, well, the area, I'm actually going to write down, not to get it confused with angle A. So the area is going to be, the formula in general is A, B, sine of angle C. Of course, in this case, we're not going to do AB sine C because we don't have sine of angle C and all that stuff. What we do have, essentially it means use one side, another side, and the sine of the angle in between. So in this case, this will be, if we call this side C, B, and A, we'll use the formula AC sine of angle B. That's going to be 48 times 32 times sine of 125.2. If we go into the calculator, 48, that was weird, 48 times 32 times sine of the angle 125.2. We get the area of triangle ABC is 1255.13. And there's our area. Just knowing the formula AB sine C, or two sides multiplied together times the sine of the angle in between. If we want to find side AC, or side B as I've called it, we can do that with the formula, well, in its general form, we would say that A squared plus B squared, by Pythagorean theorem, this equals C squared. But that only works for right angles. If we don't have a right angle, we have to use what's called the law of cosines. A squared plus B squared minus 2AB cosine of C will get us C squared. Now, we're not using A, B, and C in this like we have it written here. We're just using two sides and the angle in between. It's the same sort of setup for the area formula. In this case, we'll say this is 48 squared plus 32 squared minus 2 times 48 times 32 times cosine of 125.2 equals C squared. The easiest way to go about this problem is to just plug that whole thing in your calculator. 48 squared plus 32 squared minus 2 times 48 times 32 times cosine of 125.2 gets us 5098.8. That seems way too long for side C, probably because that's C squared. If we take the square root of that, we get 71.4. Now that seems really reasonable for me. Obviously, we're not talking actually about C, but this is the side here, 71.4. The reason that seems reasonable to me is because the biggest side is always opposite the biggest angle. And since this is a 125 degree angle and we only have 180 degrees altogether, that's probably going to be the biggest angle. And the side is bigger than the others. So there's the law of cosines. Definitely remember this as the law of cosines, and the area formula. The one last part comes down to problem number 3. Triangle XYZ. Let's draw our triangle. Let's see. X, Y, and Z. YZ is 23.5. XZ is 9.8. And the measure of angle X is 39.7. And we want to figure out what is angle Y. Now this is really different from a law of cosines problem, because in the law of cosines we had the angle in between. Here we just have a random angle on the side. This right here is a law of sines problem. The law of sines says that the sine of an angle over its opposite side equals the sine of another angle over its opposite side equals the sine of a third angle over its opposite side. Now obviously we're dealing with x, y, and z and not a, b, c here, but it's the same no matter what you call it. So we can say the sine of an angle, 39.7, over its opposite side, 23.5, is equal to the sine of another angle, in this case y, over its opposite side, 9.8. If we multiply 9.8 to both sides, we have 9.8 sine of 39.7 over 23.5 equals the sine of y. Plugging that in, 9.8 times the sine of 39.7 divided by 23.5 gets you 0.266. So sine of y is about 0.266. But it doesn't say find the sine of angle y. It says find actually what angle y is. So we can say inverse sine of the 0.266, and that should get us our angle, 15.44 degrees. Again, this makes sense to me, because if this is 15.44, that's on a side that's shorter than 9.8, or on the 9.8 side, which is the short side, as opposed to the 23.5, which has a larger angle opposite it. This was the trig review. I hope that it was useful.